Welcome everyone for joining our Women in Residential Property webinar today. We've got James Warren from Off Mains Solution, who's going to be chatting to us today about all things plot tanks. I think that's how you described it, wasn't it, James?
Very, very good, very accurate, yes.
So we will have the chat box open, so if anybody has any questions as we're going through, feel free to pop a question in the box and I'll let James know if anyone has any particular questions. The meeting is being recorded, so if you don't want your face on camera, then obviously do please switch it off. And obviously we'll share the recording for anyone that wasn't able to join in the webinar at a later stage. Over to you, James.
Thank you very much. Good morning, everyone. This is unusual to have this slot straight before lunch, but it's not of my doing, so we'll just roll with it. And also, I have a cat next to my laptop, so if any point a black animal walks in front of the screen, I can only apologise again. But right, I'm here today to talk about off mains drainage, which I'm amazed always gets so much interest. But thank you very much for coming in and being interested today. When I'm talking about off mains drainage, I am referring to cesspits, sewage treatment plants, septic tanks and soakaways. It's effectively 4% of the UK housing market that are not connected to a main sewage system. So it's about just over 1 million properties that are connected to these cesspits, septic tanks and sewage treatment plants. And it's all I do. So that's why I'm here talking about them today. And I'm going to talk about what they are, how they work, how they sometimes go wrong. And because of feedback from previous sessions, I've included some prices just to give an indication of what they cost. Whether that's of interest or not, I'm not sure, but I've included it anyway. And let's see how we go. Okay, so I'm going to start with what we're looking at now is a cesspit. It's also referred to as a cesspool. It's exactly the same thing. It's just a great big watertight structure installed underground, and it takes all the foul and dirty water from a property or properties. It could serve more than one. So if we look at the right hand side of the diagram, we see the inlet pipe. Now this takes everything from the property, so sink, toilet, dishwasher, bath, but it's not supposed to take any rainwater. None of these systems should have any rainwater going into the foul system whatsoever. Now these cesspits literally fill up and they need to be emptied. There is no exit pipe. There is no soakaway on the back end of it. It literally fills up and it needs to be emptied. And when I say empty, I'm talking about a huge truck that turns up to the property. There's a 3-inch diameter hose that gets put inside the top of the cesspit. A vacuum gets kicked on at the back and it literally removes, it sucks away all the contents to leave the cesspit empty. As soon as that happens, the process of filling it up happens again. That's all the cesspit does. It fills up, it needs to be emptied, and repeat and repeat and repeat. Now, these are perfectly legal provision for drainage, but they are the last resort. And the reason they're the last resort is because if ever there is a structural breach to the walls or the base of a cesspit, you've got untreated, unseparated foul waste going straight to ground. It can hit an aquifer, it will find a surface water, and it will be a pollutant. It will be a pollution event. So effectively, the environmental regulator and the building control officers will need to see evidence that all other off-mains drainage systems have been attempted first to then get a cesspit sanctioned. And to put that in context, in the last decade, I've only installed 2 cesspits. And that was because there was no good draining ground at the property. There was no rivers, ditches or streams to discharge into. And there was quite a big footprint of garden to insert these in. And the reason I mention the large footprint is because these tanks are massive. Just to serve 2 people, you need an 18,000 litre capacity cesspit. And in reality, that's about 5 metres long, 2.5 metres wide, 2.2 deep. And that's just for 2 persons. For every person thereafter, you need an additional 6,800 litres. So very, very quickly, these cesspits can get absolutely huge. So they're expensive to buy, expensive to put in the ground, and they typically take 6 to 8 empties per year. So they're very expensive to keep going as well. So as I said, perfectly legal, but they will always be the last resort. And I'm going to go from the least environmentally friendly to the most environmentally friendly. And we're now looking at a sewage treatment plant. Or to put the correct label on it, it's actually called a package sewage treatment plant, because going back 60 years plus, what we're looking at now would have been individual parts building up sewage treatment system. And what I mean by that is, if we look at the first part of this system on the right hand side, I've labeled it first compartment. Its actual terminology is primary zone, but it's nothing more than a septic tank inside this housing. So in the good old days, you'd have a separate septic tank, then you'd have something called a clinker bed, which is where some treatment occurred, and then you'd have something called a reed bed, where it'd be natural biological assistance with the treatment process. And after that, you'll be allowed to discharge into a river, stream, or ditch. So instead of having all those different component parts taking up a huge amount of space at someone's property, this sewage treatment plant has been created where all those processes are contained within one housing, within one asset. So on the right hand side, like I say, we've got the first compartment, which is effectively a septic tank, albeit quite a small one. And what happens in a septic tank in quiet periods of the day, such as when we're at work or when we're asleep at night, when there's no facilities being used, the septic tank is calm and natural separation occurs. And without being overly graphic, the more dense material under gravity will fall to the bottom of the tank and create what I've labeled there a sludge layer. On the flip side of that, all the items that float, so your fat, oil, grease, rags, will come to the top and form a scum layer, or sometimes it's called a crust. And the bit in the middle, and I've just left it sort of sky blue for the sake of this conversation, it's actually called clarified liquor, which I know is disgusting, but that's what it's called. And that's really, so it's still dirty water, but all the solid aspect of it has been removed at that stage. It's still dirty water. That's the only part of that first zone, that primary zone, that's allowed to go into the middle section, which I've got a second chamber. That's actually the treatment zone. And if you look at the top of that illustration, you'll see that fan. That's just indicating what's called a blower box. Now, that doesn't actually physically sit on top of a treatment plant. It can be up to 15 meters away. It can be hidden away behind a tree or a shed or an outbuilding. But that job of the blower box is to introduce oxygen into the middle section of that sewage treatment plant 24 hours a day. And the reason for that is that biomass, a really good bug, is grown inside that treatment zone. But biomass needs what us humans need. It needs food, water, and oxygen. Food and water is already produced from what we put into the first zone of the sewage treatment plant, but the biomass needs the oxygen, which is why that blower box is there. So the biomass is an amazing good bug, and it constantly regenerates. And every time it does, it makes everything cleaner. It deals with all the acids, all the toxins, absolutely everything. Super clever. And when the level inside that middle zone reaches a certain height, it goes into the very final chamber. It's called a final settlement chamber or final effluent chamber. And it's there as effectively a safety net for the whole sewage treatment plant, for if anything that could have been retained in the first two zones has somehow got through, it sits and collects in that final chamber to make sure that it doesn't actually exit the sewage treatment plant. Now, when that final settlement chamber gets to a certain level, there will be an outlet pipe. And because that treated effluent is a minimum of 95% pure water, some of these treatment plants got to 98% pure water, it's allowed to discharge to a variety of different places legitimately and legally. So it's allowed to go to a surface water, so a ditch, river or stream, whether it's free flowing or whether it's a seasonal one. It can go to a drainage field, which is a piped dispersal system, which I'll talk about a little later. It can go to a deep structured soakaway. It can go to an above ground drainage mound. All of this is a bit dull, but all I'm saying is with the sewage treatment plant, because the quality of the effluent leaving it is so good, it's odorless and colorless. There's a variety of options where it can legally disperse to. If you look at the bottom of the slide there, for a 3 or 4 bedroom house, it's going to cost you between 10 and 15,000. And I appreciate there's quite a wide price range, but depending on how good or bad the access is to a property, depending on how deep or shallow the existing drainage pipework is at the property, and depending on how good or bad the ground is for excavating, it makes a huge difference to the price to get one of these systems installed in the ground. So I'd love to say it's going to cost £10,450 every time, but it doesn't work like that. No two properties, no two sites are ever the same. No two prices are ever the same. But 10 to 15 is a pretty fair range for getting one of these in the ground. Because the blower box needs a permanent power supply, and because there are some bits and pieces that need looking after, every single manufacturer of these sewage treatment plants, of which there are about 30 in the UK, they all demand that for the manufacturer's warranty to stay valid, it must have an annual service. So at the bottom there, got the one service and one empty. The service is about £150. And when the service engineer attends, they'll carry out a variety of different tests. And during that visit, they will let the owner of the property know if it needs to be emptied now, perhaps in 3, 6, 9, or 12 months. For the sake of this slide, I've gone worst case scenario that this sewage treatment plant needs a service and an empty each year. So it's going to be about £300. The power supply is low voltage. It's the equivalent of a low voltage light bulb. So you're looking at about £70 of electric cost per year to run that blower box. So all in all, about £370 a year. So a little bit lower than sewage rates, but I think it's really good to have a self-contained sewage system. Now, I'm going to spend a couple of slides talking about septic tanks, if I may, only because the vast majority of off-mains drainage systems in the UK are still septic tanks. I think within the next 10 to 15 years, that landscape will completely change. It's getting a lot harder to install septic tanks because of the changing regulations. I think there'll be a lot more sewage treatment plants in 10, 15 years. But as a snapshot today, still the vast majority of systems are septic tanks. Historically, they were built of brick or block or concrete. From the 60s and 70s onwards, they are GRP, which is glass reinforced plastic, or fiberglass. Any sort of strengthened plastic was the preferred material from the 60s and 70s onwards. And this is typically on an older system, say 60s and further back. This is really what we find. So if ever anyone sees a photograph of a property, maybe with some site details, and there's a series of manholes in a row like this, you can tell immediately it's going to be an off-mains drainage system, simply because you only need a manhole when there is a connection coming in from the side, or if the pipework changes direction greater than 45 degrees. So to have 4 manholes in a row in this sequence, if it was going to a normal sewerage system, a main sewer, it would be a crazy dogleg system. The pipework would be going crazy in between those manholes. It makes no sense. So as a snapshot, if you see a series of manholes, that is going to be an off-mains drainage system, but it's not always crystal clear immediately what sort of off-mains drainage system that is. So on this example, we have got a 2-stage septic tank. The manhole nearest the property is MH1, which is manhole 1. Then you've got the septic tank, and then you've got what's called a distribution chamber. A distribution chamber is an access chamber where you can see if the water is getting away as it should be. If that cover is lifted on the distribution chamber and there's water holding inside it, that unfortunately is a red flag that the pipework going away from it is either blocked or collapsed, or there's a problem with the soakaway, because there should never be any water sitting in that distribution chamber. Similarly, if manhole 1, if the cover is lifted on that and there's water holding that, that's also a red flag, because that one should be free flowing. When you lift the manhole 1, any manhole cover, not that you're going to, but maybe you will, who knows? Maybe after this you'll be intrigued to have a look. But you lift the manhole cover and all you should see is a exposed half pipe at the bottom of the manhole called a channel pipe. There shouldn't be anything sitting in that whatsoever. No water, no detritus. There should be no evidence that that manhole has ever had any surcharge events in it whatsoever. It should just be free flowing. So manhole 1 at the start and the distribution chamber at the end should have nothing in it at all if the system is working well. If you lift the covers for the 2 septic tank chambers, you lift them and you're going to look down and you shouldn't really see anything. And bear with me, because I know that sounds a bit odd, but if that septic tank is performing well, it should have formed that crust. I know it's disgusting, what we talked about earlier. So when you're looking at the top side of a crust, it looks like a concrete drive. So you can't really see much, but that's actually a massive thumbs up that that tank is performing well. If you can't see that any crust on it and you're just looking at liquid inside that tank, that's actually a red flag. That means that water and the waste, everything is being pushed through that septic tank before that correct and natural separation process has occurred. And this is how it looks going. We're going to go left to right now. So we're now looking at a 2-chamber septic tank. We're going left to right. So if I can first explain that there are no moving parts inside a septic tank, and the only way they work is through displacement. So in this diagram, sorry, in this illustration we're looking at now, we're looking at a septic tank that's at its natural operating level, which means that the liquid is at the height of the inlet and outlet pipes. That's how the waste and water comes in and how it eventually is allowed to exit the septic tank. Now with displacement, all it means is if 500 litres come into the septic tank, 500 litres need to exit. And if the separation process hasn't occurred in that time, then it's going to push through matter that should always be retained inside the septic tank. And that's really critical, because if you get solids or fat, oil and grease that escape a septic tank, if it's going to a soakaway, it will quickly cause it to fail because they're not designed to handle that matter communicating with them. But if a septic tank is incorrectly discharged into a watercourse, then all the wrong matter that should be inside the tank, if it's allowed to exit, causes pollution inside that ditch, that stream, that river, whatever it may be. So the way it's controlled is A, don't let any rainwater come into these systems. Approximately 35% of all properties with off-mains drainage systems have what's called cross connections. So that's when rainwater is physically piped and connected into the septic tank or treatment plant or cesspit. If it goes into a cesspit, it's going to fill up artificially quickly, and you're going to pay a lot of money for a vacuum tanker to turn up and suck away clean water. In a sewage treatment plant, if there's rainwater connected, it will push the matter through the sewage treatment plant without it being sufficiently treated. And because most sewage treatment plants go to watercourses, it will create a pollution event. In a septic tank situation, most septic tanks should be going to soakaways, so just underground pits that disperse the separated water from septic tanks. If you've got rainwater coming through, it will push everything through before settlement. You're not going to get that crust. You're going to get the wrong matter exiting, and it's going to cause failure of the soakaway or a pollution event in the surface water. So in addition to making sure there's no cross connections, there are these T pieces. If you see on the inlet pipe, there's this sideways T pipe. Historically, that would have been made of clay. Modern day, they're made of plastic. All it means is, as all the fresh wastewater, that's an ironic term, isn't it? As the new wastewater comes into the septic tank, it hits that T-piece and it has to fall under gravity into the middle of the chamber. That is specifically so that top layer of crust isn't disturbed. On the exit side of a chamber, there's another T-piece, exactly the same. and that prevents the fat, oil and grease getting out. That outlet T-pipe only allows that separated dirty water in the middle to go into the next chamber. Now, septic tanks are either 1, 2 or 3 chambers, and the more chambers you have, the slightly cleaner the water gets before it exits. But the absolute critical T-piece, irrespective of how many chambers a septic tank has, is the final outlet T-piece. That T-piece is the last protection for the soakaway. If that has got knocked off or it's just fallen off over time, it may be that the mortar joint has just deteriorated over the decades. If that T-piece isn't in place, fat, oil and grease will get out and it will start to cause that soakaway to fail, and it's extremely common. So when surveyors lift the manhole covers on the septic tanks, they'll see the very top part of those T-pieces, and that's a massive thumbs up. If they're in place, at least that septic tank and the soakaway is protected. Now, I mentioned the material change in the 60s and 70s. So I'm not affiliated to any manufacturer in the UK whatsoever, but it's a fact that in the UK, Clargesta introduced the first glass reinforced plastic septic tank, which is what we're looking at on the left-hand side of the screen now. And this is a Generation 1 Alpha septic tank. It's called the onion tank simply because of its shape. And it allowed the same thing to happen, just separation. But instead of it being horizontal, left to right displacement for a septic tank, this is vertical. So if we look in the middle of that left-hand side illustration, you've got that sort of lampshade, that dark grey lampshade. That's called a baffle cone. That baffle cone stops the fat, oil and grease reaching the level of the outlet pipe and then going to the soakaway. What you can't see in that baffle cone is some tiny slots that allow the separated wastewater to get through, but nothing else. So it's a really, really clever design. They're really, really quite cheap to make, quite easy to install. They're a great idea. But that Generation 1 Alpha tank had a massive design problem, and that was that the baffle was held in place by steel hooks that were attached to the entrance turret to the septic tank. And you think, well, why is that a problem? It was the only place where the emptying hose could go in to suck away the contents. All that would happen is the emptying hose would knock one of those hooks. That baffle cone would stop sitting at a horizontal position. It would go at a slight angle. That oil and grease would go round the side of it, go out the outlet pipe and cause failure to the soakaway. So within 5-6 years, we're now looking at the right-hand side of the screen. This is the Generation 2 Alpha tank, and you'll see exactly the same shape as an asset, still got a baffle cone, but it's touching the sides of the septic tank. So if we imagine that main spherical section of the septic tank, in factory conditions, it's manufactured in 2 halves, and when it was welded together, the baffle cone was put in the middle, so it's almost bulletproof, not quite bulletproof, but almost bulletproof. And if I may, if I draw your attention to that darker circle at the middle of the baffle cone, that's a baffle ball. It's about the size of a football. It's effectively polystyrene and resin coated. The job is effectively to form a plug. When that tank is empty, that baffle ball will sit on the base of the tank. As the tank fills, when we use the toilets and the bath and dishwasher, etc., the ball will go with the height of the liquid level. It will hit the underside of that baffle ball. It will follow the contour to the center, and then it will wedge in the middle, and it will force the separated wastewater to go through the slots, go above the level of the baffle cone, hit the outlet pipe, and go to the soakaway. Really very clever design. And the reason I'm going to talk about that baffle ball is because I want to show you this. The reasons why it fails. I never do death by PowerPoint. They could be put in wrong, they could be damaged, they could be external pressures. I'm going to go into a couple of examples. So on the left-hand side, so these two septic tanks are from England. The customers phoned up with exactly the same problem. They had slow flushing toilets. They had saturated garden. They said that when they walked in the back garden, their feet were kind of almost sinking into the ground, and there was gurgling and noises from the facilities in the property that they weren't used to. So we went out on both occasions. We drew down the level in both tanks so we could see exactly what was going on, which is the only way you can truly understand sort of and get a holistic picture of what's going on with any of these systems. If we look at the left-hand side photograph, what we're looking at there is a single chamber cylindrical septic tank. And those two little pieces of pipe at the bottom are the inlet and outlet T-pieces. And that's why the soakaway failed on this system. There was no protection on the inflow. So the crust was all getting churned up. And there was no protection on the outlet, which meant that everything that should have been retained in that tank was allowed to exit. And that's why the soakaway failed. In the olden days, soakaways were literally holes in the ground, backfilled with rubble, clean stone, and they actually worked very well. The separated wastewater would communicate with it. The biomass that grows in the sewage treatment plant naturally grows and occurs underground because air can get through the ground to a meter depth. Air can get through the substrata at a meter depth and naturally allow biomass to grow. So underneath the soakaway is where the treatment occurs before the water then goes under gravity, hits an aquifer, and gets away to the surface water. If fat, oil, and grease are allowed to escape because the T-piece is off, it blocks all the holes in the substrata where the dirty water wants to get away. And if there's nowhere for the wastewater to go, it's going to bubble up, it's going to break ground and pool above ground and have a really soggy garden, or it's going to back up to the septic tank and cause a surcharge, or worse than that, it's going to back up all the way to the house and negatively impact all the facilities in the property. So with that one, soakaway died, had to have a replacement system, which we did. On the right-hand one, this is a Generation 2 Clargesta Alpha tank, and you'll see in the background the torchlight is bouncing off that baffle ball that I talked about. So when we emptied this septic tank, we knew straight away there was a problem because no one's supposed to see that. That baffle ball is supposed to be underneath that baffle cone. If we see that sort of witch's hat in the middle, that is the baffle cone. The ball is supposed to be underneath it. So the fact that we can see it above it tells us we've got a problem. And then if you look at that top curvature of that picture, that is the fiberglass weld, which is where that baffle cone is supposed to be sitting. So something has impacted that baffle cone. It's come out of its original design position, and that's what's allowed all the naughty stuff to get out. Fat, oil, and grease. It's hit the soakaway and caused failure. So both of these customers were exceptionally lucky. They had really good home insurance, buildings insurance policies, and both of their insurers paid for new systems to be installed. So they were very lucky. Now this one it may look unusual, but it's exceptionally common. It's referred to as a pot tank, hopefully for obvious reasons. It's actually a sewage treatment plant. When this isn't out of the ground, all we are supposed to see, if you look at the top of that, you see that green lid, it's about 3 inches high. That should be sitting at ground level. So if we were looking at this situation in normal circumstances, we would just see that green lid sitting at ground level. And that's where it's supposed to be. Now, in this scenario, I took the phone call on this. It's a few years old. A lady customer said that she had the sewage treatment plant emptied on a Friday. She came down on Saturday morning, opened the curtains in her dining room, looked out into her garden, and saw what we're looking at now. Now, this happens in a perfect storm or imperfect storm, I suppose. What happens in this scenario is that there is sustained and heavy rainfall to make the ground saturated. We're then at a situation where the customer has their annual empty, it's normally annually, of their sewage treatment plant. But the problem is that these sewage treatment plants, certainly from the 60s, 70s onwards, are made of a material similar to that of a hull of a boat. And funny enough, they are really good at floating. So in this scenario, we've got that buildup of water because of the sustained rainfall. So we've got hydrostatic pressure, that body of water sitting in the ground around it and underneath that asset. It then coincides, unfortunately, with an empty. So all the weight of the contents is being physically extracted. And even though this weighs 400 kilograms empty, that is nothing compared to how powerful hydrostatic pressure is. So unfortunately, the only thing keeping that in the ground was the weight of the contents, and they had been removed the day before on the annual empty. So sometimes, I mean, this is quite an extreme version. If we look from the base where the stone is to the top of the green lid, that's almost 2 meters. So it is quite an extreme example of a pop tank. Typically, they only move a few inches, but that's all they need to move for the pipework to come out of alignment. And then anything that comes through the pipework from the property won't get inside the sewage treatment plant. It will hit the side of it and then trickle under it and create some sort of disgusting soup underneath where the treatment plant should be. On the flip side of this, I have seen a more extreme version where it physically popped out of the excavation and it was sat next to it. It literally popped, the whole thing had physically popped out the ground. And that's just because of hydrostatic pressure. Now, with hydrostatic pressure, if it doesn't make the tank pop out the ground and rise, it will start to collapse in, whether it's the side walls collapsing internally, or it will just collapse the base of the sewage treatment plant. In any scenario, it's almost impossible to repair them and they'll need replacing. Luckily, again, for this customer, I sound like I'm some sort of sales rep for insurance, but the customer's buildings insurance company paid for replacements. They're very lucky. A few winters ago, I dealt with one of these every single day through the winter. And considering there's about 100 installation companies in the UK, it just gives you a flavour that this is a very common scenario. What should happen is that the experience of the emptying engineer should come into play when they start to drain down the liquid level. If they hear any creaking, if they start to feel the ground move a little bit, they should stop their activity immediately. They should refill the tank with fresh water to create that equilibrium of pressure, and they should go from site. Come back maybe in a month, 6, 8 weeks, when the ground's had a chance to dry out, and this will not be a possibility. So it really is down to the competency of the engineer that attends in that perfect storm, in that perfect set of conditions, as to whether they should continue that emptying activity. This slide is really on there because traditionally this presentation was for either building surveyors or insurance company surveyors or companies like myself that go out and assess these for various reasons. And sometimes it can be quite hard to ascertain why something's going wrong. What sometimes what we hear is just as valuable as what we see. For example, with septic tanks, they should be emptied once a year. And they get emptied once a year, not because there's a problem, it's because it's good habit. You don't want that sludge layer at the bottom getting too high. Now, if you hear that the tank used to be emptied annually, then it increased in frequency to an empty every 6 months, and then every 3 months, and every 6 weeks. That's not a habit, that's a reaction. And that would be a reaction to a surcharge event. And that only happens when there's either a collapse or a blockage in the pipework leading away from the tank, or if it goes to a soakaway, it means the soakaway has failed and there's nowhere for the water leaving that septic tank to go anymore. So that will create a reactionary need for more emptying. Boggy patches in the garden is a good example of something going wrong. And also, it can be quirky things like an abundance of stinging nettles. I know it sounds a bit odd, but stay with me. Stinging nettles love ammonia. So if there's a soakaway failure, there could be ammonia in what we create and put into a septic tank that is trying to normally disperse to ground, but it can't because the soakaway's failed. It will find a lower point in the garden and it will just sit somewhere underneath the layer of the surface. It will just sit there and that will encourage nettle growth. Now, it may just be that it's a horribly overgrown garden and there's just stinging nettles. But if you've got other items, you can start to piece together that there might be a complete sort of holistic system failure. And that could just be one thing. I mean, if you drive on a rainy day and you might see a sort of rainbow effect in a puddle on the ground, that's what you can get in puddles in people's back gardens if a soakaway fails. The water breaks ground and you have that oil that should be retained in the tank that's got through and it's just sitting in the water above ground level. So you can start to piece together if there is a problem and then have the system emptied, holistically survey it and find out exactly what's going on. When a tank is surveyed, I know this is a bit boring, but stay with me because it's important in my world. We insist on the tank being emptied whilst one of our guys or girls is carrying out the survey. And that's because we want to see the liquid level inside a tank before, during, and after an empty. Now, although it's a bit disgusting, the liquid level is absolutely critical as to whether there might be a problem. It should be sitting, when we saw a previous slide, and there's an outlet pipe. If you think of that as a clock face, the liquid level should be sitting right at the bottom at about 6 o'clock. Now, if we look inside the tank and it's sitting above that level, that's a sign that the water can't get away. So there might be a blockage, a collapse, or complete soakaway failure. If we look inside that tank before it's emptied and the liquid level is below the height of the outlet pipe, that tells us immediately that there must be a structural breach, and therefore water is escaping out of the walls of the tank into the surrounding ground instead of exiting through the correct mechanism of the outlet pipe. So it focuses our engineers' minds on where to look and where to concentrate on the survey. Also, if we're there while the tank is being emptied, if there's any water backwashing from the outlet pipe, that is another massive indicator that the soakaway has failed, that pipe work is holding water and it's waiting for the tank to be emptied for it to backwash into it. So it's all these things. You're listening and looking out all the time for structural breaches or water ingress or egress, and it's so important we see everything. Inside the tank, there's a GoPro underneath that torch, and there's a video taken on a horizontal, then it's tilted down and up, and between those three videos, we get a complete picture of that asset. We're looking for the structural condition. We're looking to make sure it's performing, not polluting. We want to make sure that its capacity is adequate for the property or properties that it serves. And it all goes to create peace of mind for, it's normally a pre-purchase situation, or sometimes the seller will commission the survey, but it's just to make sure that it's compliant and safe and structurally sound. And this is really exactly what I just mentioned there. It's what they're doing. They're making sure first of all, it's making sure it is what it's supposed to be. It seems that a lot of people say they've got a septic tank, whether they've got a septic tank or a treatment plant, it seems to be a kind of catch-all reference for any off-mains drainage system. So we confirm what the system is, where it goes, is it the right size, is it structurally sound, are there any problems, and we go on and on. Are there any cross connections? And what we're looking out for is adherence or not to all the overarching regulations and standards in my world. And they are Building Regulations 2010 Part H Section 2, the BS 6297 2007, which is a 46-page document all about drainage fields, which is piped dispersal systems, which I'll talk about in a moment. British Water created a document called Flows and Loads, and they're currently on the 4th edition. And that tells anyone how to size any of these systems for any property, whether it's domestic or commercial. But the one that I'm going to talk about now, if I may, is the General Binding Rules, which came out in 2015. And the premise of the General Binding Rules. So first and foremost, it came out in January 2015. It's only applicable to England, and everyone seems to think it's the whole UK or England and Wales. This is just England. The environmental regulators for Wales, so NRW, for Ireland, NIEA, for Scotland, SEPA, they've got their own rules and regulations, which are extremely similar to ours in England, but there are some differences, and the general binding rules are really where those differences are highlighted. Now, to give it its correct title, it's called the Small Sewage Discharge General Binding Rules, SSD GBRs. And small sewage is defined as 2,000 litres per day being discharged to ground, so some sort of soakaway system, or 5,000 litres per day discharging to a surface water, so a ditch, river, or stream. And to put that in context, we as individuals allegedly use 150 litres per person per day. If we have a 3-bedroom house, the rules dictate that a 3-bedroom house can have a maximum population of 5 people. The calculation is number of bedrooms plus 2. So a 3-bedroom is recorded as 5 people, irrespective of whether there's 5 people living there or not. 5 times 150 litres. So that 3-bed house is producing 750 litres per day. If you have another 3-bedroom house coming into the same system, that takes us to 1,500 litres. We're still thumbs up. We're still within the daily limit. If we add one more 3-bedrooms, we've got 3 houses going to 1 septic tank. That will take us to 2,250 litres going to ground. That takes us outside of the general binding rules, and then a permit from the Environment Agency will be needed. So that's a defining moment of these rules. They're only applicable if you've got less than 2,000 litres a day going to ground or less than 5,000 litres a day going to a surface water. The idea when this regulatory reform was introduced back in 2015 was that there was a 5-year period. There was always references to 5 years or 60 months for all septic tanks in England to be assessed, and then if they were non-compliant, they were to be addressed in that 5-year period. And this was to really stop a massive issue of septic tanks historically being discharged to ditches and rivers and streams, which still happens, unfortunately. But this is really what the general binding rules was created for. So it's a brilliant tool for protecting our environment and protecting pollution events. The only issue is that there was no ability to proactively get outbound messages to septic tank owners to tell them about this, because there is no database in England for septic tank owners. Now, if any off-mains drainage system requires a permit from the Environment Agency, those specific properties will be on a database. But unfortunately, if you're on that database, that means you're already compliant because you've already had to have gone through the permit process. This regulatory reform was for everyone that didn't have a permit, that no one knew about, where we didn't know where the system was, we didn't know where it was discharging. So you had this fantastic environmental protection tool, but hardly any ability to get it and deliver the message to the very people that needed to know about it. So on one hand, it's a fantastic tool, but on the other, it is really frustrating because it was only by chance if a company like mine or an emptying company popped out and happened to see one of these systems, and at that moment in time, we could let the customer know that they might want to have an inspection of their system. So they're all supposed to be addressed in that 5-year period. No one's got any accurate data on what percentage were actually addressed. I'll be amazed if it was a percent, in all honesty. But anyway, that aside, because they weren't all addressed, we were all waiting to see the start of 2020 what else was going to be done, because obviously this master plan hadn't come through properly. So in January 2020, on the government website, it said that any non-compliant system should be dealt with in a 12-month period after discovery. So that's great. That makes perfect sense. 12 months should be plenty long enough to address any non-compliant system. The further issue with that statement, though, was that there's no legal duty on the company or persons that found or discovered a non-compliant system to let the environmental regulator know about it to start that clock ticking. So this really comes down to the honesty and integrity of anyone involved in an off-main drainage system to acknowledge that there is a problem and then progress with it in a compliant fashion to adhere to the new regulations. Also, there was the introduction of a pre-1983 rule whereby the British standards surrounding wastewater plants in England was only introduced in 1983. So any system that can be proven to be installed before 1983, if it's still performing as expected and not polluting, they effectively don't have to adhere to the general binding rules purely because of the age of the installation. If you have an installation that's post 83, but pre 2015, more times than not, we're having to go to the Environment Agency to say, we've got this system, does it need a permit or not? And then we have to wait for a response. So it's a little bit painful, but at least it creates an audit trail for the asset owner or the potential purchaser or the vendor, whatever the dynamic is where it's being checked. So that there are safety nets everywhere, but they just need to be thoroughly looked at, and these systems have to be examined with special equipment so we can identify what they are, where they're going, are they discharging compliantly or not, and then what needs to be done if they're not. Another addition to the rules, and that is the bottom point on this slide, is that a non-compliant system should be addressed and included as a condition of sale. Again, another missed opportunity to say which party should be funding the investigation, which party should be funding the price to put the system right. So it's great that it's been thought about and highlighted, and now all of us stakeholders, all of us professional stakeholders are aware of a potential issue. We know that it's got to be investigated. We know that it's got to be included in the minutiae of the property transaction, but it still comes down to head versus heart of the purchaser, whether they're going to accept a reduction in the price or whether they're going to take it anyway and take it on the chin and have to sort it out themselves. So it's not bulletproof in its entirety of saying exactly which party should be funding what percentage, but at least it's making all of us aware that we've got to wrap it up as part of the sale if a non-compliant system is found. Oh, excuse me, I'm coming off the back end of a cold, so apologies for the sniffing. I know it's disgusting. What we're looking at now is an illustration from 2015 onwards in England. If a septic tank has been installed, it has to look like this. So if we look at the white onion, we're saying that's the septic tank. They come in all shapes and sizes, but this is just for this illustration. The white asset is the septic tank. The little black asset in front of that is called a distribution chamber, which must be there. A reg state, they must have a distribution chamber. And then the blue lines coming off the back end of it is a drainage field. Now, a drainage field is a set of pipework. It's either 4 or 6 inches in diameter, and they have to be laid almost flat. This is 1 in 200. So it's got a gradient fall of every 200 meters length. It's only going to fall 1 meter. So that means that the wastewater that leaves the septic tank is entering that drainage field and then really calmly and slowly flowing through that pipework. There are small perforations or slots at the bottom of this drainage field pipework, which allows that wastewater to drip through it. It then falls onto the stones that are bedding that pipe in. The biomass grow on those stones, and again, it gets treated as it goes under gravity through the clean stone. The biomass grows, treats the water, and then it gets away through an aquifer, through the substrata and away. Now, a septic tank separates, the drainage field treats. So that's why they're both as important as each other. But to comply with the general binding rules, this is the exact design that should be against a septic tank. Now, if there's been a post 2015 installation of a septic tank and it's not going to a drainage field, it must have a permit to discharge from the Environment Agency. If there isn't a permit to discharge, in default, that is a non-compliant system and it must be addressed. And what I mean by being addressed is there needs to be a percolation test done, which is a couple of test pits dug in the ground to make sure that a drainage field can work and be supported in that area. And then that percolation test will tell you how big the drainage field needs to be, and then it needs to be installed against that septic tank. So a drainage field is, technical term, is a subsurface infiltration system, and it's designed to very slowly, very calmly allow that wastewater to get to ground in a calm and compliant fashion. Effectively, as it goes through really slowly over 3 or 4 decades, the perforations and the stone and the substrata under it will effectively fail in sequence. So as you go on through the decades, that drainage field will eventually go to the last parts of the pipework and then fail. And they can't last forever. You should get 30, 40 years out of a drainage field. And these are the challenges. I've kind of touched on them a little moment ago, but sometimes you can be told misinformation, not maliciously, just an ignorance from the owner or a neighbour if they're intervening, saying what the system is or where it goes. You don't know above ground what the system is, its location. You certainly don't know its condition or capacity. It's absolutely imperative. This isn't a sales pitch for me. For any company doing these inspections, it's imperative that the system is completely emptied so that a survey can be done inside the asset itself, and then a conventional CCTV camera survey can be carried out leading away from the asset to see where it goes and to make sure it's performing, and also back to the property to make sure there's no issues with the pipework and to check for cross connections. Because as I said, there shouldn't be any rainwater or surface water coming into these systems. I suppose that is a bit of a sales pitch. That's just what we do. Please follow me on LinkedIn. I try and be as informative as I can be, considering the subject matter that I have to deal with. So please follow me on LinkedIn, and I'll try and entertain you in my own special way. And that's me done. I'm bored of my own voice, so I'll leave it to Donna to broker any questions if there are any.
I think someone asked at the beginning, James, whether you'll be issuing copies of the slides. Is that something you're able to do? Send me a set of the slides so I can send them around.
I can send it to you, Donna. Absolutely, yes.
Lovely. And then I think there was a question about how often tanks should be empty, but I think you kind of indicated really that it should be at least annually, I think, wasn't it?
It should be once a year. I mean, in a scenario, excuse me, in a scenario where you have a single occupant and they don't use the facilities very much, in that scenario, you could probably stretch to 2 or 3 years. But if you've got a stereotypical 2.4 family in a property, then it should be annual emptying.
We had another question that says, do the binding rules not apply to a sewage treatment plant at all?
They do from a capacity and dispersal perspective. Now, the general binding rules were predominantly to capture the septic tanks that were illegally discharged into surface waters, but it's 27 separate points about any off-mains drainage system, and it refers to the other overarching regulations as well as a reminder. So it does encapsulate sewage treatment plants as well, how they're supposed to be maintained, how they're installed, and where they're allowed to disperse to. So any off-mains drainage system is included in the general binding rules, but there is more emphasis on the illegally discharging septic tanks.
Thank you. So someone's asked whether you offer a service of reviewing private drainage questions to make sure that we are asking the right type of questions in our survey questionnaires.
But the first, that's an uncannily timed question, because 2 weeks ago, a solicitor asked me to do exactly that. So it only took me sort of 15 minutes to go through. So yes, I certainly do offer that service and very happy to. And to be honest, I love that sort of thing, because for the sake of 15, 20 minutes of my time, if it just helps to ensure that nothing slips through the net, and therefore there are no nasty surprises further down a transaction trail, or certainly when the incoming purchasers take ownership, I'd much rather have these conversations now and upfront and tweak. When I saw a list of questions, they were really good. They just needed to be phrased in a slightly different way, and a couple of additional questions thrown in just to make sure there was no get out of jail free card for the like the TA6 and things like that. So yeah, please file them over. Very happy to help, either through LinkedIn, or Donna, I'll give you my email address if you'll be happy to pass that out as well. That'd be great.
Lovely. I've had some questions about what areas you cover for doing surveys.
Full UK, everywhere.
Great. We've had another question that says, what do we do if sellers simply can't give any information to questionnaires? Other than tell them they need to go and get a survey.
Well then, I've been told in no uncertain terms that it's buyer beware, it's on the purchaser, and therefore it's for all of us to impart that knowledge to the purchaser to say the onus is on you. Commission a full survey and find out exactly what's going on. Personally, if I'm allowed to have my opinion, I think it should be all on the vendor. And I cannot believe that it's the complete opposite. In fact, I think if you're marketing a property, you should be able to tell an incoming purchaser what the system is, where it goes, how often it's emptied, who the emptying company is, give them all the information they could possibly need to allow the purchaser to make an informed decision. But I fully appreciate, in my naive mind, that's not how we work in the real world, and it's all on the purchaser. So irrespective of who commissions a survey needs to be carried out to then create that a sort of overarching picture of what the system is it performing well, does it need to be upgraded or completely replaced, and what the what the price is for doing that. Some of these run to anything from 10 to 20,000 pounds. So it's, to my mind, that's a lot of money. And if there's a chance to have it captured in a price negotiation, then that is the correct time to do it.
Lovely. You mentioned on some of the tanks that had popped, and you mentioned that the house owners had good buildings and have insurance
Yes.
that covered it. So is this something that we, that buyers need to ensure that they are discussing the fact that property is served by off mains drainage with their insurer then?
That's a really good point. Yeah, I mean, there's a section on all of our home insurance policies called accidental damage to underground services. We'll all have that line of cover, but unfortunately, dependent on the quality of your insurer, the definitions will be extremely specific or loose. And there's some of us will be lucky and it's all inclusive. And if you bought a really inexpensive policy, there'll be so many attached exclusions and terms and conditions that you'll never be covered. So absolutely, if you're buying a property with an off-mains drainage system, it's going that extra mile to check with your buildings insurer that you are fully covered for the asset itself and wherever it discharges to. Because predominantly, insurers get funny when it crosses boundaries into third-party land. But a good insurer will mirror your legal responsibility, whether it's in boundary or whether you're going into third-party land. So spending a few minutes speaking to the home insurer, buildings insurer, to make sure you're fully covered for the physical location of all the drainage pipe work connected to that system is critical, and it could save a huge amount of money if the claim is covered.
Thank you, James. We've also got a question saying, is there anything we need to bear in mind for shared systems where they're served by multiple properties?
That's a brilliant question, and I'm almost embarrassed I didn't put a slide in about that. Irrespective of how lovely the neighbours are at a moment in time, always have a written agreement. As a minimum, a written agreement informally, as long as it's in writing. My preference is to have a management company and have it completely formalized, because I've been involved in way too many scenarios where incoming property owners aren't aware of the historic rules and agreements. They disagree with them. They then have issues paying their percentage against maintenance and clearance costs, and it just gets really messy really quickly. So yeah, absolutely written agreements saying who's going to organise the emptying, the maintenance, the servicing, if it's a treatment plant, who's supplying the electricity, who's going to collect the funds, at what intervals is this going to be done, every month or once every 6 months, once every year. Get it all written down so it can be transferred to the incoming owners without any he said, she said. That's the quickest way that that neighbourly vibe breaks down. We're involved in it way too often. So yeah, written agreements whenever it's a shared scenario.
Thank you. Does anyone else have any more questions for James? Can't see anything else is coming up, James. So thank you for that absolutely informative presentation about the different types of private drainage. That's really helpful. And thank you again for offering to look at various drainage questions. I'm sure you're going to get a plethora of those coming through very shortly.
That's fine, not a problem.
That's lovely. But many thanks again. So I'm
Awesome.
sure we'll be able to get the link from Ali to send around to everyone if anyone wants to share it with colleagues that weren't able to watch today. But there's lots of thank you messages coming through for you, James.
Oh, lovely. Well, thank you for the invite. It's very much appreciated.
Thank you very much, everyone.